So page 340. Which questions do you guys have? Yes. 4. So it's just f of x is equal to 4 to the x. And you're supposed to find f of negative 0.2. So what we have to just find is 4 to the negative 0.2. What's the easiest way to find that answer? Calculator. Just grab your calculator and type it in. So is this going to be a big number or a small number? Why do you say small? So the negative tells me it's probably going to be a small number, right? But that decimal, when you raise it to a decimal, that does some weird things too. But yeah, this ends up being a small because it's a reciprocal kind of thing. So 0.75. Yeah.
So wait, can we change it into the reciprocal, like say like 1?
Yeah, like this would be the same thing as 1 over 4 to the positive 0.2. But I don't know, like that to me is a weird number. Like what is that decimal? If it was 1 over 4 to the 2 and you just wrote 1/16, great. But to the 0.2 power, yeah, like that needs some more clarification. So we should probably go a little farther with that one. So, anything else on those? Yes. Oh yeah, go. Yeah.
30.
30. Glad you asked those because I actually wanted to talk and show you 29 and 30. So I'm actually going to do 29 first. I know you didn't have to do this one. Now, first off, is this exponential growth or is this decay? Why do you say decay? Look at the base. Is this number bigger than 1 or smaller than 1? It's bigger, so it should be growth. This should be a growth graph. But something interesting happens. When you, if you plot some points, you plug in a 0. Well, 0 squared 0, anything to the 0 power is going to be 1. So yeah, sure enough, it's still going to go through 0, 1. That's definitely going to happen. You plug in a 1. 1 squared is 1. 2 to the 1 is 2. So yep, goes 1, 2. You plug in a 2. 2 squared is 4. 2 to the 4th power is like 16. So here we're way up here. But yeah, it looks like exponential growth, right? This is 29. I'm going to do 30 in a second. Okay? Now, but something interesting happens on the left side. When I plug in a negative 1, what does that squared do to that negative 1? It makes it positive again. So what happens is we don't have a normal exponential growth graph that on this side's going to be going to the asymptote, right? What ends up happening is it's growth on this side. What's happening over here? It's going to be growth again over there. So you get kind of a double exponential growth graph. It looks like a what? Looks like a parabola. Makes sense it kind of looks like a parabola because of the x squared there, but it's actually not a parabola, okay? It's just it's a double exponential growth graph kind of thing. Now, what's weird, now you look at 30, and we negative there. If we kind of do it the same way and we plot a couple points, so you plug in a 0, 0 squared 0, there's no such thing as negative 0, so 2 to the 0 is 1. Right? So it's still going to go through 0, 1. But you start plotting positive points here, you get 1, negative 1, 2 to the negative 1 is 1/2. What's this side of the graph going to look like? It's not going to go down, but this side's going to be the tail end, the asymptote end, right? It's going to get closer and closer and closer to 0. Is it ever going to touch? No. So right now it kind of looks like an exponential decay graph, right? But what's going to happen when I plug in a negative 1? That squared is going to do what? make it positive again, but then the negative makes it negative again, you're going to get right back to a half. So now you're going to end up having a double tail end. Does that kind of make sense? So these are kind of some weird graphs with these. And what causes the double growth? Like instead of it having, this one doesn't have the, like this part doesn't have the tail, right? And this doesn't have the tail. It's only the growth sides. In this side, this exponential growth graph, right? It doesn't have the growth side. It only has the tail side. What's causing that? That squared, right? Now, we are going to do some stuff with graphs as well. There was another one I wanted to make sure I hit, which was number 24. Was it like 3 to the 2x minus 1? If that minus 1 wasn't there, and it was just 3 to the 2x, does that 2 really do anything here? Not really. I mean, it's going to make it a little steeper, but in essence, it's still going to be an exponential growth graph. But that minus 1, that actually is going to do something. Do you guys remember just last week when we were talking these types of graphs? Well, that parabola, those shifts. What is that minus 3 actually going to do to this parabola? Do you guys remember what those shifts were? What's that minus 3 do? That's going to move the whole graph down 3 spots. And what's that plus 2 going to do to the graph? Move it. Remember, left and right are always backwards. So this is actually going to be a left 2. So instead of a parabola here, right, at 0, 0, that parabola is going to get moved down 3 and left 2, right? So it's going to actually look like that. Does that make sense? These exponential graphs shift exactly the same way. When you see plus or minus on the inside of the exponent, do you think that's going to be an up and down or a right and left shift? It's on the inside. That's going to be right and left. Now the weird part is you would think this should be a right shift 1. It's actually not. It's actually a right shift 1/2. And the reason is that 2, you should pull that out. So it actually ends up being a shift to the right 1/2. And the way I would show that key point, instead of being at 0, 1, it's just going to be over here. Other than that, it's an exponential growth graph. That's not necessarily going to be on the test kind of thing, but understanding those shifts, that actually is going to, we're going to talk about logarithms today. We are going to talk log graphs soon. You will need to be able to shift those things. So keep in mind, just remember that if it's on the inside, it's a right or left shift. If it's on the outside, it's actually up and down. If you saw something like y to the 2x versus y to the 2x plus 3 minus 4. This is just your basic exponential growth graph, right? We go through 0, 1, get closer and closer to 0, right? What's that plus 3 going to do? Left 3. So that point, 0, 1, isn't there anymore. It's over here, right? But also, what's that minus 4 going to do to everything? Move everything down 4. So this point isn't here, it's actually here. 1, 2, 3, 4, right? So this is actually where that point ends up. The asymptote, if I take this asymptote where it's getting closer and closer to 0 and I move it left, does that do anything? It's a line. But moving it down, there would be an asymptote down here and end up looking something like that. Does that kind of make sense? Yes?
What if there was a 2 in front of the half?
Here,
Yeah, 'cause what happens?
I'd have to factor it out. So instead of being a left 3, it'd be a left 3/2 if there was a 2x here. So the way the shifts actually work, if you saw this, what you'd actually have to do is factor it like this. Get that to be a single x there first. Now I can see the shift. Does that make sense? Am I going to put one of these on the test? No, I am not. I want to clarify that. But I did want to show you this because, number one, it's going to help us understand how the log graphs shift. And the more exposure you get to that, it's just going to make chapter 2 when we get there and I show you all those shifts. It's all, I mean, we're going to do a lot with that kind of shifting this year. Make sense? Any other question in the homework? Awesome.